What's the area and the perimeter of this shape formed from two rectangles? If you build it using algebra tiles, what do you build first? Do you build the perimeter and use that to find the area? Or do you build the area first and then use that to calculate the perimeter? Okay, so this is another task I like to use to get pupils familiar with algebra tiles and their dimensions. And whenever I use it, it's always a 50-50. Some students prefer to build the perimeter first, some the area. Now I would suggest that building the perimeter first is a little bit more complex, as we're about to see, because I'm going to do it both ways. So we've got this 2x at the top, and then down the side we've got 3x plus 1. And you might have that discussion about what's going on in the corner here. Why don't they overlap? Well, we're trying to find the perimeter. It's the inside of these tiles that we'll eventually be counting. Along the bottom here, we've got this 2x, which is the same as the top, because it's rectangle. And then we've got an extra length of x plus 4, the same as the top bit there. So x, plus 4. 1, 2, 3, 4. And then up the side, an x plus 1. And then again, we're going in x plus 4 again. So 1, 2, 3, 4, and an x. And at this point, pupils that are doing the perimeter first have a bit of a problem, because this length here is obviously going to be 2x, but we have this overlap going on here. So to get around that, you might want to stress that this length here is 1. So what we can do is just take that one out there and just slide this x along. And then to work out the perimeter, we just start adding in the inside of this shape. Now you need to be really careful, because counting the x's is easy. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12x. But when you count the units, it's not just 1, 2, 3, 4, 5, 6, 7, 8, 9. You've got to remember this extra unit here of 10, because we removed it. So the whole perimeter is 12x plus 10. The area comes out nice and easy now. We don't count any of the perimeter, remember, we just need to fill this space in with tiles that fit. So we end up with 1, 2, 3, 4, 5, 6, 7x squared. Then let's put the x's in. 1, 2, 3, 4, 5, 6, 7. So 7x. And then we've got an extra 4 units here. Now they won't fill it necessarily like this, but they might have the tiles in a slightly different order, like sometimes they end up with something like that and so on. But ultimately end up with the same expression for the area, 7x squared plus 7x plus 4. Okay, let's have a look at how the people that do the area first get on. Okay, so the area first people, they have to kind of do some calculations like you almost might do with the grid method when you're working it out, because we've got this length of 2x at the top and it's 3x plus 1 down the bottom. So 3x times 2x is going to give us 6x squared. So it's going to look like that. And then the extra 1 times by 2x is an extra 2x's. So you can see we're almost like modelling the grid method here a little bit. Then what about this bit down here? Well, we know it's x plus 4, and we know this distance is x plus 1. So we're going to need an extra x squared there, and 4 x's. 1, 2, 3, 4. Then just check this length here is x plus 4. And then the last few tiles that are obvious to place because it needs to form this rectangle. This here needs to be an x, and then we've got our 4 unit tiles here. So I think doing the area first, it turns out is a much easier build if you can get that initial couple of tiles placed. But whenever I do this in the classroom, I like to have different groups on different tables. And like I say, normally it's 50-50 whether they end up with a perimeter model or an area model first. And then they can go around and they can look at each one and try and make sense of both of them, which I think is powerful to make sense of the problem solved in multiple ways. Let's just check these areas, then make sure we agree with what we got in the previous one. So we've got 7x squared plus 7x plus 4, which is the same area. And then is the perimeter the same as well? So remember, we've got 12x plus 10 for the perimeter. So let's count all the x's. We've got 1x there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12x. And then what about the units? Do we get 10? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And where's the extra 10, 1 for 10 come from? Well, it's this length down here. So there's the 10. So we've got exactly the same area and perimeter, but we're counting it in different ways.